In this episode, we're going to do a troubleshooting challenge, specifically documenting the network. I'll show you how to do it, and we'll talk about the concepts along the way. Our employer has been hired to take over the administration of a corporate network because the previous network administrator has left the company. The network documentation is missing and needs to be recreated. Our job is to document the network and network devices, including all device addressing and logical interconnections. We will remotely access network devices and use network discovery to complete a device table and draw the network topology. This is the first part of a two-part series where we will use the documentation that we create here to guide us to troubleshoot the network in this next part. As we investigate and document the network, make sure that we take notes of any problems we discover. Greetings to my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Tech Tracer Lab 12.6.1 Troubleshooting Challenge, Document the Network. I have the packet tracer file open. On the left side, I have our work area where we'll be doing our configurations, looking at our different information. This gives us our topology. On the right side, I have our instructions. On the way bottom right is the packet tracer activity window that opens up when you open up the packet tracer file. It has the instructions in there. In the upper right, I have a Word document of those same instructions. Reason I have a Word document of those same instructions is we have a lot of information to fill out. Putting in a Word document will allow me to save that information. Here's our topology. We have one internet server. We have 7 PCs. These all PCs are connected into the networking cloud. Now, what happens in the networking cloud, we don't know at this point in time. We're gonna have to figure that out, what's happening in this networking cloud. On the right side, we have our addressing table. Our addressing table looks pretty empty. We're gonna have to go through, we're gonna have to fill out a lot of this information. So I scroll down here, we have the objectives. We're gonna test our network connectivity, look at host addressing, default gateways, access those, and draw our network topology when we're done. The scenario here is your employer has been hired to take over the administration of a corporate network because the previous network administrator left. The person who was administering the network, they left, they took a different job, whatever the reason is, they're no longer with the company, and now you've been hired to come in. The network documentation is missing and you need to recreate it. So we're going to go ahead, look at our devices and recreate it. Our job is to document the host and network devices, including all device addressing and logical interconnections. So we have to go figure out all the addressing schemes, how the devices are connect in. We're going to remotely access the network devices and use network discovery to complete the device table and draw a topology. For those of you who are playing along, this is part 1 of a 2-part series. The next video will be on the second part here, the Packet Tracer Troubleshooting Challenge, using documentation to solve issues. As we investigate and document our topology, also we're going to make some notes of issues that we discover that don't adhere to the practices that we have learned so far. Instructions. Part 1, test connectivity. Ping between the PCs and the internet server to test the network. All PCs should be able to ping one another and the internet server. Okay, so we're going to start our documentation right away. What I'm going to do is I'm going to use a feature here of Microsoft Word. Underneath View, we have Split. I'm going to turn this into a split screen. That will allow me down here to see my instructions on what I'm doing, but on the top one, I'm going to scroll up to our addressing table. That will allow me to add information in here as we go, and I don't have to scroll back and forth. First thing we got to do is document all the IP addresses on our PCs. I'm going to click on PC1, slide it over, make it a little bit bigger, click on our command prompt. From here, I'm going to go ahead and type in ipconfig, and it's going to list out our IP addresses. First one here is our fast Ethernet. That is the only network connection on our PC. There is the Bluetooth, but it's not enabled and it's not part of our network troubleshooting. So we're just concerned with the fast Ethernet connection. And so this is our network interface card. The device we are on is a host. So this is a PC host. So filling in our table here, we're on PC1. We are looking at the network interface card. It is a host. It's not a router or a switch. The IP address is listed right here. 192.168.1.153. Make sure I'm typing in the right field. 192.168.1.153. Subnet mask listed right below that. 255.255.255.0. 255.255.255.0. And our default gateway is listed right below that. 192.168.1.1. 192.168.1.1. Okay, I'm just going to go ahead and do all the PCs with that. So I'm on PC2, command prompt, type in ipconfig. I spell ipconfig correctly. So PC2, we are on our NIC. This is a host. IP address is 192.168.3.50. Subnet mask is 3255.0, and our default gateway is 192.168.3.1. On the PC3, ipconfig. This is our NIC. It is a host. IP address of 192.168.4.115. Subnet mask 255.255.255.0. Default gateway of 192.168.4.1. Onto PC4. PC4, command prompt, ipconfig. The interface is our NIC. We are on a host. IP address of 192.168.5.83. Subnet mask of 255.255.255.128. A little bit of different subnet mask. And our default gateway 192.168.5.1 on the PC5. PC5 ipconfig. This is the NIC. We are on a host. IP address of 192.168.5.227. Subnet mask 255.255.255.128. And our default gateway 192.168.5.129. On the PC6. Command prompt ipconfig. This is a NIC. This is a host. IP address 192.168.2.48. Subnet mask at 255.255.255.224. And their default gateway of 192.168.2.33. Onto PC7. ipconfig. This is a NIC. This is a host. 192.168.2.67. Subnet mask of 255.255.255.224. Default gateway of 192.168.2.65. So that is our PC information. PCs 1 through 7. All PCs should be able to ping one another. So I'm going to go up here from PC1 and I'm going to go ahead and ping all the other PCs. First one I'm going to ping. I'm getting this right from my addressing table here. this IP address, 192.168.3.50. Hopefully we're doing an ARP lookup the first time through. Timed out. There's our pings that work successfully. To confirm that, I'm going to repeat the command. Up arrow once, hit enter. Looks like all 4 pings are going to work. We are able to ping PC2. Let's go ahead and ping PC3, 192.168.4.115. Once again, hopefully we're doing an ARP lookup. It'll time out the first ping. What it looks like we're doing. 3 work, repeat it, up arrow, hit enter. All 4 have worked. We're able to ping PC3. Let's go ahead and ping PC4. PC4 is 192.168.5.83. Hopefully we're doing an ARP lookup here. Timeout. Next 3 should work. Repeat that quickly just to confirm all 4 are going to work. There we go. All 4 worked. Let's go ahead and ping PC5, 192.168.5.227. And hopefully we're doing a ARP lookup. First one timed out. Next 3 worked. Repeat that command to make sure all 4 worked. That looks pretty good. Let's go ahead and ping PC6, which is 192.168.2.48. And doing the ARP lookup. First one fails. Second, third, and fourth work. Repeat the command. Up arrow, hit enter. All 4 pings have worked successfully. And let's go ahead and ping PC7, 192.168.2.67. Ping 192.168.2.7. First one timed out. Next 3 work. Repeat the command just to make sure all 4 have worked. And last thing is to ping our internet server. We can get our internet server IP address right here in our topology, 203.0.113.27. Ping 203.0.113.27. Probably have to do an ARP lookup or 2. Press timed out. I have several ARP lookups to do inside of this cloud. So the first 2 failed. I'm guessing these 2 were doing ARP lookups. The next 2 worked. We're just going to confirm it, run that command again. So up arrow, hit enter. All 4 pings are working successfully. So we do have connectivity. And because ping PC1 can ping PC2, and because PC1 can ping PC3, because PC1 can ping both of them, I'm assuming PC2 and PC3 can ping each other, and I follow that logic all the way through. So part 1, test our connectivity. Part 2, discover PC configuration information. Go to the command prompt of each PC and display IP settings. Record information in the document table. Oh, we sort of did that out of order. We already did that step. We have all of our information entered right there. So we're done with part 2. On to part 3. Discover information about the default gateway devices. Connect to each default gateway device using Telnet protocol and record information about the interfaces that are in use in the table. The VTY password is Cisco and the privilege exec password is class. So we have to go to each device and Telnet into that. First thing we should be looking at here is Telnet. What's wrong with using Telnet? Telnet sends information in clear text. So this is part of that list we should be documenting on improvements we can make to the network. Instead of using Telnet, we should use SSH. So I'm going to go ahead and write that down here. So instead of using Telnet, use SSH to remote into devices. So from each PC, we're going to Telnet into its default gateway. We're on PC1 here. We're going to start with PC1. The command here is Telnet, and then the default gateway, which we can get from our addressing table where we typed in ipconfig. Our default gateway is 192.168.1.1, 192.168.1.1. VTY password is Cisco. And then we can go ahead and get into privilege exec mode by typing enable. And that password is class. There we go. Must have spelled it wrong the first time. Record information about the interfaces that are in use in the table. So what interfaces are being used here? We're going to record that information into the table. Well, we are on branch 1. Branch 1 here, we're in privilege exec mode, so we can go show IP interface brief, and it's going to list out our interfaces that are being used. It says we have 5 interfaces. The last one is the virtual interface, which we're not using. Then here we have gig 000 has an IP address and the protocol is up. And gig 001 is unassigned. It's administratively down and down, so we're not using that one. We're using serial 010, has an IP address and it's up and up. And serial 011 is unassigned and we're not using it. So we're only using 2 interfaces here. And so what device are we on? We are on branch -1. How do I know that? That's the name of our device right here. This is a router because we do have interfaces. How do we confirm it's a router? We can do a show version. Show version shows us the version of software. But I spacebarred through there. We can look here. This is on an ISR, which is a router. We can also see that when we showed the interfaces, that there wasn't a whole lot of fast Ethernet or gigabit interfaces signifying a switch. So that tells us we are on a router. Oh, the interface or the device type is a router. And we're using 2 interfaces. Now, the command I used, if I up arrow twice to show IP interface brief, gave us a nice summary. But the one thing it's missing is the subnet mask. So we need to use a different command. What we're going to use is show IP interface. Show IP interface starts here. It says, okay, this is your, this is the interface. So gig 000 is up and up. This is the IP address and it's a /24. So right here we can get our subnet mask is a /24. Now the interface once again we're on is gig 000. We can fill that in gig 0/0/0. We're on a router. The IP address we can pull right from here, 192.168.1.1. Oops, I wasn't in the right field. Here we go, 192.168.1.1. The subnet mask was a /24. So our /24 is a 255.255.255.0. And then our default gateway, because we're a router, routers don't have default gateways. They have gateway of last resort, but that's what the routing protocol. They don't need a default gateway because they are. And so this is non-applicable here. The second interface, so show IP interface. I had to repeat the command to kick me out for some reason. This is gig 01, which we have. It's telling us that there's more information. They display that more information. What we can do is either hit enter, takes you down line by line, or you can hit the space bar and it gives you a whole screen of information. Here's gig 001, which is down, so we're not using it. Here is serial 010, which is up. We are connected to that one. Here's the IP address, and then our subnet mask is a /30. So we are on branch -1. We are looking at serial 0/1/0. This is a router once again. The IP address we can get from right here, 92.168.0. Yep. Typing in the command prompt, not typing in the field. 192.168.0.2. Then we have our subnet mask. The subnet mask here is a /30. When we convert that into dotted decimal notation, it's 255.255.255.252. And once again, because we're a router, we don't have a default gateway, so that's an NA right there. And that was all of our devices. Or that was all the interfaces that were being used on that one. Okay, let's go ahead and do this for PC2. PC2. Telnet, and we're telnetting into our default gateway on PC2, which is 192.168.3.1, 192.168.3.1. Our VTY password was Cisco, and then we can go ahead and type in enable, get us into privilege exec mode, and that password was class. Now, we can see that we are in a device called factory. We're in a device called factory. Connected into factory. And this time, instead of doing a show IP interface brief, because I had to go into the normal show IP interface, I'm just going to start with the show IP interface. And then it'll tell me what interfaces I'm connected to. So gig 000 is up and up, so I'm using that interface. Here's the IP address and the subnet mask. We can go ahead and enter that information in. We are in gig 000, so G0/0/0. This, well, I'm going to scroll down. I'm going to hit spacebar and look at it. So we got a gig 001. Then we have serials. Oh, we got serials and only 2 gig interfaces. That means we're on a router. I scrolled back up to my top. So this is a router here. Our IP address is 192.168.3.1. 192.168.3.1. Subnet mask is a /24, converted into dotted decimal notation, 255.255.255.0. And we are a router, so we don't have a default gateway. Scrolling down, here is gig 001. Protocol is up. We have an IP address on there also. We are on factory. I'm filling in my table. We are looking at gig 0/0/1. This is a router once again. Our IP address is 192.168.4.1 with a /24, so it's 255.255.255.0. And we don't have a gateway because we are the gateway. Okay, I'm going to scroll down after our gig 001. Here is serial 010. It's up. We're using it. Has an IP address and a subnet mask. So we are still on factory. We are using serial 0/1/0. This is still a router. The IP address is 192.168.0.14. And with a /30, once again, convert that into dotted decimal notation, is 255.255.255.252. Because we are the router, we don't have default gateway because we are the default gateway. Okay, back here, looking at this. Then we have serial 011 we're not using, and VLAN 1 we are not using. Okay, so that takes care of the default gateway for PC2. Let's go ahead and do PC3. Telnet into PC3's default gateway, 192.168.4.1. 192.168.4.1. Password here is Cisco. Enable class. Show IP interface. Start off. Oh, we are connected to factory again. So PC2 and PC3 are connected to the same router. They're connected to factory. So we got all of that enabled. So we have gig 000 listed here already. factory gig 00. Hit the space bar, takes us down. We got gig 001. We have that documented already. Hit the space bar again, serial 010. We have documented right here. And then serial 011 we're not using, VLAN 1. So we have all of that documented already. That tells us PC2 and PC3 are connected to the same router. Okay, let's go ahead to PC4. PC4 telnet into the default gateway of PC4, which is 192.168.5.1. 192.168.5.1. Cisco is our password. Enable. And class. First thing we notice, we're on a new device. It's called HQ. So our new device is here is HQ. We're connected into it, so we have at least one connection. And I'm going to go ahead and do the show IP interfaces again. Starting off, gig 000 is up, LAN protocol is up, but we don't have an IP address assigned there. So we don't have an IP address, but it's up and up. Down now we have gig 000.1. .1 means we're using sub interfaces on a router. We're doing some sort of router on a stick where we have multiple VLANs, and that router is going to serve for or allow us to connect in between those VLANs and to the outside networks. And so we do have these interfaces here that we need to document. So we got gigabit Ethernet 000.1 is up. We have an IP address. Okay, so back to our addressing table. Gigabit 0/0/0.1. Oops, sorry, .1, not /1. So gig 000.1. We are on a router, because the router is the only one that can have sub interfaces. Our IP address is 192.168.6.1, and that was a /24, so 255.255.255.0. And because we're the router, we are the default gateway, so we don't have that, doesn't have a default gateway. So this is another NA. Back over here in my PC4 window, looking at the HQ router, I'm going to hit the space bar. Brings us to gigabit Ethernet 000.5 as an IP address and a subnet mask. Let's go ahead and document that. So HQ G 0/0/0 dot, what was it, .5? Yep, the sub interface was .5. We are on a router. The IP address is 192.168.5.1, and then this is a /25. When you convert a /25 into dotted decimal notation, you get 255.255.255.128. And because we're the router, we get another NA here. Back into my PC4 window, looking at HQ, hit spacebar again. No new interfaces. Here's another new interface. Gig 000.10. We have an IP address and a subnet mask set up for that. Okay, let's go ahead and document that. So device name is HQ, interface is G 0/0/0.10. We are on a router. That IP address is 192.168.5.129, and that is another /25, and the /25 is 255.255.255.128. And we are the default gateway again. Back in my PC4 window, looking at the HQ router, hit the space bar. Here's gig 001, which is down, so we're not using it, but we are using serial 010. It's up, and it has an IP address assigned to it. Let's go ahead and document that. We have HQ, and that was serial 0/1/0. We are still on the router here. IP address of 192.168.0.10. /30 into dotted decimal notation is 255.255.255.252. And we are the default gateway once again. Back in my PC4 window, looking at the HQ router. The serial 010 is what we just did. Spacebar again. Serial 011 is not being used, and neither is VLAN 1. So we have all of those interfaces, interfaces documented on PC4's default gateway. Let's go ahead and do PC5. Telnet to the default gateway of PC5, which is 192.168.5.129. 192.168.5.129, asking for our VTY password of Cisco. Type enable to get into privilege exec mode, and the password is class. We are in the HQ router again. We are in HQ router. PC5 also connects into it. So PC4 and PC5 do connect into the HQ router. Okay, so we got all that information. Let's go ahead and look at PC6. PC6. Telnet into its default gateway. PC6 default gateway 192.168.2.33. 192.168.2.33. Asking for our password. Cisco enable class. We are now in branch 2. That's a new device to us. We had branch 1, but we didn't have a branch 2. Let's go ahead and enter that into our chart. So we are on branch -2. And let's use the show IP interface command again. Gig 000, we're not using. Gig 00, well, actually, we're using gig 000. It's up, but it doesn't have an IP address associated. What does that mean? The physical interface is up. That means we should have a sub interface. So here's gig Ethernet 000.1. So this is a sub interface of that physical one. It's up, and it also has an IP address. Let's go ahead and document that one. That is gig 0/0/0.1. We're on our router again because we have our sub interfaces. IP address of 192.168.2.1. And that's a /27. When you convert a /27 into dotted decimal notation, you get 255.255.255.224. We are the router, so we are the default gateway. So once again, we get another NA. Back into PC6's window, hit the space bar. Here is gig 000.32. Another sub interface we can look at and document. So we have branch -2 here. So that's gig 0/0/0.32. This is still a router. Has an IP address of 192.168.2.33. /27 again is 255.255.255.224. And a big NA because we are the default gateway. So back in PC6's window, hit the spacebar, look for more interfaces. Here is gig Ethernet gig 000.64. We're up and we have an IP address. Go ahead, enter that one in. So branch -2 for gig 0/0/0.64. This is still a router. IP address of 192.168.2.65, and that's got a /27 again, which is 255.255.255.224. And we are the default gateway. Back into PC6, looking at the branch 2 router, hit the space bar. Gig 001 is administratively down. We're not using it. But here is serial 010. It's up, and we are using an IP address with the subnet mask of /60. So let's go, or /30. Let's go ahead and enter this in. So branch -2, We are at G. Nope, we're not on G. We are on serial 010. This is still a router. IP address of 192.168.0.6/30 is 255.255.255.252. And we are the router also, so we get another NA. Back in the PC6 window, hit the spacebar again. Got serial 010, spacebar again. Serial 011 is not being used. VLAN 1 is not being used. So we have all the interfaces there. That is PC6. Let's go to PC7. Telnet into the IP address for our default gateway of PC7, which is 192.168.2.65. 192.168.2.65. Cisco enable class. Oh, look at this. On PC7, our default gateway is branch 2 also. That's the same one as PC6. So PC6 and PC7 share the same device as their default gateway, the same physical device. Now, we did have sub interfaces on those. So it is probably doing some inter VLAN routing. We did have sub interfaces here, but they are on different networks, but they still share the same device characteristics, the same physical device, the same interfaces. Okay, so that takes care of part 3, discover information about the default gateway devices. On to 4, reconstruct the network topology. In this part of the activity, we're going to continue recording information about the devices in the addressing table. In addition, you'll start to diagram the network topology based on what you discover about the devices. Okay, so we're going to come in and we're going to start documenting our network. I'm going to start with PC1. Well, that's a pretty nice place to start. It did terminate our connection to our default router, so we're going to have to do that again. Now, the easy way to do that is just hit the up arrow, repeats the last command you entered. I hit enter, Cisco, type in enable, and then password here is class. We are now in privilege exec mode on our device. Part of this step is drawing your network topology. What I have here is I have a piece of paper, pad of paper, and I have a pen. And I'm going to start drawing out my topology. Right now I'm on PC1. So I'm going to draw a little square, write PC1 in it. And then I'm connecting into the branch 1 default gateway, which we know is a router. So we're going to connect those two up because those are connected. I'm currently in there. What we're going to do here is use the routing tables in each router to learn more about the network. Make notes of your findings. So to use the routing table, it's show IP route. It'll list out our networks. Okay, we have 2 networks that are directly connected to us. I'm going to slide this over. Well, I'm going to probably leave it right here. Once again, we're from PC1 into branch 1. We have a directly connected network right here of 192.168.0.0, which is directly connected on serial 001. And then we have a second directly connected that's started by the C right here of 192.168.1.0 is directly connected to gigabit Ethernet 000. We scroll up to our table and we look at our branch 1 information. Branch 1 information shows us we have, just branch 1. We have 2 networks. We have 2 interfaces. They're on different networks. Gig 001, gig 000 is 192.168.1.1, which is this network right here, the one we have highlighted. That's that network. If we also look at the IP address for PC1, we can see it's on the 192.168.1 network. So that's the network that connects up between R1 and, between our router that we're on, branch 1, and PC1. So I can go ahead and write that down in our table. That 192.168.1.0/24 is this network. We can tell you that the interface is configured with this IP address that's directly connected. So this is the .1. So I'm going to write that down by my interface. And then our PC, we can get from our table here, is 1.153. So I'm going to write the .153 down there. Now, this is what it looks like. I am no artist, so this could look pretty messy and sloppy when I'm done. Usually what I do is I write this out on pencil and paper once. I'll come back, I'll redraw it in pencil paper a second time after I figure it out, and then probably the third time is when I'll actually put it into a computer using some sort of drawing program. That network that connects to PC1 is this one. The other network that comes off here is the one that's directly connected to our serial. So I can draw a line out from branch 1 going out to wherever, that this is the 192.168.0.0/30 network. I can tell you that the interface that's directly connected to our PC is .2. And once again, this is our serial 010 interface. So serial 0/1/0 interface. This interface down here was gigabit Ethernet 000, so I can also write that down. So gig 0/0/0. And I hit the space bar to see that. And then all of these other routes. Wow, look at all these other routes that we've learned through OSPF. We've learned about all of these other networks through OSPF. So they exist somewhere. If we look here, we can see that the 192.168.0.4 network is out there. We can look for other networks. We have the 192.168.4.0 network. If we look up here in our PC table, we can see that PC3 is on that network. So these are all existing somewhere in our configuration. Right now, this is what my drawing looks like. Not pretty, but it is a start. And that's where you have to do, because once again, you've been hired to document this. You need to start somewhere. Now we're going to go to each router and access these. So this is PC1. So we were able to figure out our directly connected networks there. Then we have a bunch of OSPF routers. We even have a gateway of last resort here. Looks like it was propagated using OSPF. It's got the little asterisk here, meaning that's the candidate for the default route. And that goes out our serial serial 010 interface. Okay, let's go ahead and look at the device connected to PC2. We lost our connection. I hit up arrow again. Just repeat that command to get us into our default gateway. Type in Cisco for our VTY password. Type in enable. Class is our enable password. We are now into privilege exec mode. We can go ahead and type in show IP route. I'm going to make this window a little bit bigger. See how it wraps a little weird if it's not big enough? If I pull it out a little bit bigger, right, left, it wraps nicely. It is saying I have more information, so I'm going to hit the space bar once. Here's all the routes, all the networks we know about. Once again, we do have our gateway of last resort set. We've learned a bunch of information, networks from our OSPF routing protocol. How do I know it's OSPF? It starts with an O here. If I scroll up, the O stands for OSPF in our codes. But then we have several directly connected networks and locally configured interfaces. So this C here is a network 192.168.2/30 is connected to serial 1. The other thing to look at is we are on a different router. We are on a different router, so we can see that from the first one. Our first one, we are connected to branch 1. Now we are on the factory router. The factory router has 1 directly connected network, 2 directly connected networks, and 3 directly connected networks. On my chart here, now this isn't connected up here to PC1, so I'm going to start over with PC2 below that. I'm going to write PC2. The IP address of PC2, if I look over here, this is a /24, so our network portion is 192.168.3.0, so I can write that in there. I'm also going to put down that we are connected into the factory router. Our network address is 192.168.3.0. We got that from right here. The first 3 octets are our network portion. 192.168.3.0 is our network address, and that was on a /24. PC2 has a .50 address from its NIC card, and then we are connected into, we got to find where the 192.168.3 network is. So this is the .4 network information. Nope. Here's the .3 information, and that's connected into gig 001. So now we can say on gig 0/0/0. No, yep, it's 000. My fault. I think I said it wrong. So it's connected to gig 000, and that IP address here we can get from the L line. Once again, L stands for, this is our local interface. It is 192.168.3.1, so I can put a .1 by that interface. We now know that. And then we have 2 connections coming out from factory 1. We have 1, which is another gig interface. So that's this network right here, 192.168.4.0/24. That interface is .4.1, and that's connected out the gig 001 interface. So I can go ahead, I draw a line out of the factory router. This is the 192.168.4.0/24 network. It is coming out of the router we're on, the factory router of gig 001. So I can write that down, gig 0/0/1. And then the IP address is .1. We can get that from our local link. That's a .1. We have a third address, or third connection, that's up here. That's on this network, 192.168.0.12/30, connected on serial 001, and that IP address is configured as 0.14. So I can draw that out. So this is coming out our serial 0/1/0 interface. It has a .14 at the end. The network here, once again, was 192.168.0.12/30. Now, I don't know what any of these are connected to, but I can get that information all out of my show IP route table. Let's go ahead and do PC3. Once again, to make this window bigger, going left to right. I have to telnet back into my default gateway, up arrow, hit enter. So we can go ahead and type Cisco, enable, and class. Okay, I typed enable wrong. To break it, I hit Control F and 6 at the same time. It stops it. So I can go ahead and type enable and our password of class. We are now in there. We can do a show IP route. Hit the spacebar to display all of our information. So on the factory router, which we just were, when we were on PC2, we were on the factory router. Now we're on PC3, we're also on the factory router. We can see that we still have our serial connection with the same network, same subnet mask, same connection. We have the other 2 networks, 192.168.3 and 192.168.4. But the difference here is we're on PC3. PC3 is on the 192.168.4 network. PC2 is on the 192.168.3 network. So they're on different networks. PC3 is on the .4 network. The .4 network is connected to our gigabit Ethernet 001. So I can draw that on my drawing. I can draw out of my gig 001. I can draw another square here, write PC3. And my PC3 address is .4.15 or 115. I can write it up here. Once again, this is what it looks like. Not very pretty at all, but once again, you're starting it out. It's not going to be pretty. Okay, that takes care of PC 1, 2, and 3. Let's go ahead and do PC 4. PC 4. Make this window a little bit bigger. Oh, we are also kicked out here, so I can go ahead, just do an up arrow, hit enter. We can go ahead and type in Cisco. We can type in enable and class to get us into privileged exec mode. From here, we can do a show IP route. You type in IP correctly. Oh, hit the spacebar to display all of our information. We are now on the HQ router. So from PC4, we're connected into the HQ router. I'm going to draw another square, write PC4 in it. I'm going to draw another, I guess technically circle, and write HQ in it for our HQ routers. Connect those up. We have one directly connected network. We have a second directly connected network. We have a third directly connected network. And we have a fourth directly connected network. The last last three directly connected networks, notice these are all on sub interfaces. These sub interfaces, we're doing router on a stick with these sub interfaces on our factory router. Okay, let's go ahead and document those. Get that information down. So PC4's IP address from our table, 192.168.5.83. We have a subnet mask of 255.255.255.128, which is a /25. Okay, so 5.283. How I do it is find the IP address close enough without going over. So we have 5.83. If you look in our routing tables, the 5.83, that's a 0.8. That's probably way far away. Here for this network is 192.168.5.1. So I mean, we have .5.83. This is .5.1, so that's fairly close without going over. The next one is .5.128. That one went over, so that one's out. This one here is 192.168.6. That's definitely over. So our candidate, we're connected right here to this device. We're connected to the gig 000.5 interface. And so coming into the HQ router from PC4, I can go ahead and write gig 0/0/0.5. That has an IP address. We can get that from our local line right here of .5.1. I can write .1 down here. Our network address is 192.168.5.0/25. I can write that down, 192.168.5.0/25. And our PC4 address is .5.83, so I can put the .83 by its interface. This is what I got so far for PC4. Now, I know we're doing sub interfaces with different networks. What I'm going to do is I'm going to go on to PC4. Now, when we looked here, remember we did PC4 and PC5, we figured out that they were both connected into that same router. They were both connected into their same physical default gateway, but we had sub interfaces. So I'm going to go into PC5. Make the window a little bit bigger, right to left here. Our connection was terminated. Hit up arrow so I get my telnet command back. We can go ahead and enter in our Cisco, or our VTY password, which was Cisco. Type in enable, and then class is our privilege exec password. Show IP route, and spacebar to show it all. We are on the HQ router. HQ router is just what we had on PC4. This is PC5. PC5's address is 192.168.5.227 with the default gateway of 5.129. Another way to find out which interface you're looking at is, because once again, remember, the default gateway is the router interface. So look for that IP address, 192.168.5.129. Look for this IP address in our routing table. It will be one of the L lines. So we're looking for .5.129 at the end. Is that it? Nope. Try the second one, .5.129. We're looking at the L lines, the link lines. So this is .5.1. We're getting close. Here's the third L, .5.129. That's the address we're looking for over here. So we are connected to this device. PC5 is connected to not this device, but this network, this particular sub interface. And here's our default gateway. So I'm going to draw PC5. And once again, this is connecting into the HQ router. That was the router that PC4 was connecting into. So I'm going to draw another square by the HQ router. A PC5 in it, connect that to the HQ router. Now, this network here is 192.168.5.128/25, so I can write that down. 192.168.5.128/25. The IP address on the router itself is .129. We can get that from the L code, the local link code, so that's .129. PC5's IP address is 5.227, so I can write that down here, .227. Now on HQ, there's two more connections that we're not using. Here is one connected to our serial interfaces, and the other one is .6 network, 192.168.6.0 network. Now, we're not using the .6 network anywhere that I know of, but we are using this .0.8 network, the serial 010. That should be our WAN connection, and I'm assuming that the HQ router is connected to another device. I don't necessarily see that being connected right here anywhere. I don't necessarily see the IP address 192.168.0.10 being anywhere used in our IP address. Oh, it's right here. Okay, so it's on the HQ router, but it's not being used anywhere else as a default gateway. So it must be a serial interface. And so what I'm going to do is from my HQ router on my map I'm drawing a line out. I don't know what it's connecting into, but it is the serial 0/1/0 interface. It is the 192.168.0.10 it is the 192.168.0.8/30 network. So 192.168.0.8, so 192.168.0.8/30 network, and the IP address coming out of the HQ router is a .10 at the end, so I can write that down here as a .10. This is what my drawing looks like for PC5. Okay, that takes care of PC5. Let's go ahead and do PC6. Make the window a little bit bigger, going right to left. I hit enter. Oh, my connection's been closed. Up arrow once. VTY password of Cisco. Go ahead and type enable. Our privileged exec password is class. I am logged in. Now I can do the show IP route statement. Hit the spacebar to display all of this. We are now connected to branch 2. This is nothing I have documented here, so we're going to start doing a new device. What I have done here is I've ran out of paper on my notepad here. I'm going to rip it off and I'm going to start a second page here. I'm going to draw a square for PC 6. I'm going to draw a triangle for branch 2, or sorry, draw a circle. This is for branch 2 router. I'm going to connect those up. PC 6's default gateway, which is the connection on the router, is right here. So 192.168.2.33. I'm going to look for that IP address here in this routing table. I'm going to look at in the L lines because that's our local interface, what configured IP address. So we're looking for 2.33. So this is 0.6, not there. This is 2.1, not there. It's getting close, but it's not there. Here is this one, 2.33. That's our default gateway right here for PC6. So this is the network it's on. It is this C statement, directly connected network, and L statement. It's these two statements that PC6 is connected to. So PC6 has an IP address of 2.48, so I can put my .48 here. It is on the network of 192.168.2.32/27, so I can write that network address down, 192.168.2.32/27, and that interface has an IP address of .33. That's our default gateway, so I can write that down here. And that is going into, once again, this is the information we're looking at, that is going into 000.32. So that is going into gigabit 0/0/0.32 interface. There's several other connections. We can see that we did some route summarization here. We have 6 subnets, 3 directly connected networks, 2 of those local IP addresses configured. The IP addresses on there. I'm guessing these are all sub interfaces. But then, if I had to guess, this one right here, this is our WAN connection. So out of the other side of branch 2, I'm going to draw another line. I'm going to write serial 0/1/0 there, because that's the interface it's going out of. This is the network address, 192.168.0.4/30. So I can go ahead and write that up there, 192.168.0.4/30. And our configured link address here is a .6. So I can go ahead and write that down here. I don't know what this is connected into right now. I don't know, but that's what we do know. This is what my PC6 connection looks like. Go ahead and minimize PC6, open up PC7. Let's go ahead and get that information. We timed out here, so up arrow once, gets it back to our telnet. Cisco is our VTY password. We can go ahead and type enable, and then class is our privileged exec password. We're in there. We can go in and show IP route. Here's our routing address. Hit spacebar, display all of it. Looking back here, we are on branch 2. Well, PC6 was connected to branch 2. PC7 is also connected to branch 2. We have all of these sub interfaces in here, so I'm willing to bet that PC7 is connected to one of them. Let's go back, look at our addressing table. Here's PC7. Our default gateway is 192.168.2.65. This is the address on the router. So let's look for one of the L commands here. One of the links that has this IP address configured. So we're looking for 2.65. Here's the first L 2.1, nope, not it. Here's the second L, 2.33. That's where PC6 was, but we're on PC7 now. Here's the third one, 2.65. This is the network that PC7 is connected to. So this is the network information. This is the link information, the IP address on that link, the default gateway. Okay, let's go ahead and draw that up. Now, I don't have to draw a new branch 2 router here. PC7, and I'm just going to draw a square right below it, put in PC7. That's connected into the branch 2 router also. The network address here is 192.168.2.64/27. So I can write that down, 192.168.2.64/27. The IP address of the interface on the branch 2 router is .65. I can write that here. The IP address for PC7 is 2.67, so I can write .67 here. And our connections are all coming out the gig 000.64 interface. So I can also write that down. Gig 0/0/0.64. This is now what my drawing looks like for PC7. PC7. Okay, so we looked at the routing tables on each one. We figured out what information we could get. Now, discover non-gateway devices. So we've discovered all the gateway devices. So let's go ahead and discover non-gateway devices. Use a network discovery protocol to document neighboring devices. Record your findings in the addressing table. At this point, you should be able to begin to document device interconnections. How are these devices interconnected? Okay, let's go ahead. Let's start on PC1. That's where we've started everything else. Our connection's been terminated, so I can just hit up arrow again to pull up our telnet command. Our VTY password is Cisco. Type in enable, and class is our privilege exec password. From here, we can go ahead and use our discovery protocols. I'm hoping CDP is enabled, so let's go ahead and say show CDP neighbors, and it shows we have some neighbors. Now I got to go back to my original drawing on S1. S1 here says we are connected into, so we are on branch 1, running CDP neighbors on branch 1. It says I am connected to switch B1. My local interface is G000. The far side is a 2960, which is a switch. How do I know it's a switch? It says capabilities a switch, or an S. Codes say S is equal to switch. And the far port is gig 01. Looking at my original drawing for PC1, I had PC1 going right into my branch 1. That's incorrect. We have to go into a switch. So it goes from PC to switch to router. I need to go ahead and make that change. So I'm just going to draw a square right in the middle, and right in there, SWB1. SWB1. So from branch 1, it's going out my gig 00 port. I already have gig 00 port on branch 1 connected, but it's going into this switch on gig 01. So I can write gig 0/1 right there, showing you that's how it's coming in. Now, where's the PC connected into? We'll actually have to connect into that device to see. And then we also see there's a second entry. There's a second entry that's called hub. Boy, I hope it's not a hub. As we look across, my local connection is serial 010. If I look at my drawing, serial 010 is the line I just drew off into the middle of nowhere, and I don't know what it's connected into. Now I know it's connected into this thing called a hub. I really hope it's not a hub. So serial 001 is connected. That's from branch 1, and it's connected into this thing that has a capability of R. Capability of R. Somebody named their router hub. Kind of funny. So somebody named their router hub, which is an ISR 4000 router, and that is connected up to serial 010 on the far end. So there is this router out there, and I'm going to draw another circle. I'm going to call it hub, and this is coming in on serial 0/1/0. So now branch 1 is connected to hub. So out of branch 1, it's going from serial 0/10 to hub of serial 0/10 also. We can get that IP address if we go ahead and do a show CDP neighbors detail. Here's the information about switch 1. Switch 1 has an IP address. Okay, so we need to start writing some of this down in our addressing table. First, we have hub here. Hub has serial 0/1/0. It's a router. I don't know the IP addresses yet. We're not looking at switch SB1. We're looking for the hub information. So I'm going to hit spacebar. Here is the device named hub. Its IP address is 192.168.0.1. I can go ahead and write that information in there. 192.168.0.1. Its far side IP address, serial 0/10, which we already had in there. And this being a router does not get an IP address. Now we need to figure out what the subnet mask is. A couple ways to do that. What we're going to do here is look, this is the port on hub 1 is serial 0/10. The port on the device we're on, which is branch 1, is serial 0/10. If we scroll up to branch 1, serial 0/10 has an IP address, or sorry, a subnet mask of a /30. That should be the same on our network. And so 255.255.252 or /30 is our subnet mask. So we can go ahead and fill that in. So 255.255.255.252 gives us a connection into a device, into a router called hub. Okay, so that's looking pretty good. I'm going to go down. I'm going to minimize that. Then I'm going to go into PC2. Lost my connection, so I up arrow once, enter in. So Cisco, enter, enable, enter, and then class for our privilege exec password. And let's go ahead and do a show CDP neighbors. Here we have a couple of other devices. This PC2, we are now into the factory router. And so that's the second router I have written down on my map, which has got 2 connections coming in, which goes to a switch here, gig 01. That is the, or gig 001. That goes to PC3 according to my map. And switch F1, gig 000, that goes to PC2. So these are the switches that are used on the LAN for connectivity. But here's our other device. We have the hub device connected in here again. Well, we're interested in that information, so let's go ahead and do a show CDP neighbors. Sorry, show CDP neighbors detail. And let's go down until we see the device of hub. So here's the device for switch for F1 or F2. Here's the device of switch for F1. Hit the space bar. Here is our device of hub. That's the one we're interested in. Hub, the side we're on, factory, is connected into serial 001, but it then on the device called hub, that far port is connected to serial 021. Now I can draw a line, because right now I have factory just with a line that's off to nowhere. I can draw that line up to the hub router. I can tell it goes into serial 0/2/1. And it also has an IP address of 192 192.168.0.13. Oh, I forgot to write down the IP address from PC1. Scroll down. Here's the IP address. I forgot to write that down on my diagram. So that was 192.168.0.1. That was a .1 here. That was PC. This was PC2 where we're looking at factory here. I'm going to minimize this. Go ahead and look at PC3 here. Reestablish my telnet connection. Cisco is my VTY password. Type in and enable. Class is my privilege exec password. Show CDP neighbors. Gives me the two switches again and my hub. My hub says on the factory router we're on. So factory serial 010, which I have written down, is connected into this device called hub with its connection into serial 0/2/1. We're able to figure that out. Now, confirm the IP address. We can do a show CDP neighbor detail. Go down to, hit the space bar down to our device hub. And here's our information. We can actually fill out that in our addressing table. We have hub here. This hub is connected to, and this is the far one, so serial 021. So S 0/2/1. Hub is a router. How do we know it's a router? Right here it says capabilities of a router. Its IP address is 192.168.0.13. The subnet mask, if we look at my drawing, I have it written down as a /30, so that's 255.255.255.252. And because we're a router, we don't have a default gateway. Okay, let's go and look at PC4. PC4, reestablish our telnet connection, Cisco, enable class, show CDP neighbors. So we're on the HQ router. HQ router has a switch that's connected, I'm guessing, that is providing local connectivity. And then we have that another connection into our hub router. That's central. It looks like it's going to be a central router where all of our devices are connecting into. I'm going to take my drawing where it says HQ, and I just had that line dangling there. I'm going to draw it up to the hub. Now I can say that that's connecting into on the hub device into serial 020. So I can go ahead and write that down, serial 020. If I do a show CDP neighbors detail, I can get the IP address of hub here. So here's hub. That IP address we're using to connect into is 192.168.0.9. So I'm just going to put a .9 by the hub because I already have that network address written in there. Okay, that was PC4. Let's go ahead and do PC5. Establish my telnet. So it's Cisco, enable class, then show CDP neighbors. Once again, PC4 and PC5, these two connected into the same physical device, except they had sub interfaces. And you can see that we have the sub interfaces listed here, what we're connected into, but here is the hub we're connected into. And once again, it's the same device name. It's a router. It's an ISR 4300, and it's connected into on the hub router. This connection is 020. That's what I have written on my diagram. So here's the first page of my notes. As you can see, it's starting to look fairly messy. It's starting to look fairly messy. And that's, like I said, the first time drawing it, that's what you're going to get. Okay, let's take a look at PC6. Reestablish my telnet connection. Cisco enable class. Show CDP neighbors. Here it looks like we have another intermediary switch for our local networks, but here's our hub device. Once again, it looks like our branch 2 router is connected into this device called hub. Right now from branch 2, I just have this line drawn off to nowhere. So now I can connect it up to another router. Yes, I'm going to have hub listed twice, but they're on 2 separate pieces of paper. I'm going to make sure that I know that that's the same hub between the 2 sheets of paper. That is coming into, on the far side, into the hub device. It's coming into serial 011. So I'm going to write that down. And then to get the IP address, it's show CDP neighbors detail. And let's go down to the host or to the hub device. Right here is the IP address. I'm just going to write down .5 by that interface because I already have the network information that I got earlier written down. I now have all of our devices connecting into that hub device. Okay, so we have that set up. It's looking pretty good. Last thing we need to do here is discovering it. Is we had these switches that interconnected the PC to the router. And let's go back and see if we can get any information about that. I'm going to start with PC1 here again. I'm clicked in the window, reestablish my telnet, Cisco enable class, and I'm going to do a show CDP neighbors. Forgot neighbors there. So show CDP neighbors. This is the hub. We have our information there, but now we have this SWB1. I have it written down here. Let's see if we can find out any other information. It's connected into the far on switch B1. It's connected into gig 01, so I have that written down. Let's go into the show CDP neighbor detail. See if we can find out any information about it. So here's our device, switch B1. Oh, we can even get an IP address. Well, 2960 is just a layer 2 device, but it has an IP address. What that means is we have set it up for management. It's been set up for management, so now you can sit in your office and configure it. Go ahead and document that information. Oh geez, we forgot to document the last couple networks we found here for the hub. We're missing a couple of them. Because we have 1, 2, 3, 4 networks into the hub. So we have 1. So then we need a third network, and that would be from the HQ router. And so that's coming in on our serial 020. So serial 020. Hub was a router. It has an IP address, and once again, I have it documented, so I can just write that down, 192.168.0.9, sorry, .9. That was a /30, so that's 255.255.255.252. And this is a router. It's the default gateway, so we don't have a default gateway. And we had the fourth connection coming into the hub. That was from branch 2. Let's go ahead and type in hub. And that went into serial 011. So serial 0/1/1. We're on a router. That IP address for my drawing right here was 192.168.0.5. That had a /30 address. There's subnet mask also, so 255.255.255.252. And the router is, or the hub, which is really a router. Routers don't have default gateways, so once again, this is not applicable. Okay, back to what we were looking at. We're on PC1. We see that VLAN, that we set up a VLAN here with an IP address so we can remotely manage our switches. We can go ahead and do that. Let's go ahead and document that information. So this is SW-B1. We are coming in, not necessarily on an interface, but on a VLAN here. So we're on VLAN. SW-B1 capabilities is a switch here. So we can see that we are a switch. And that IP address is 192.168.1.252. That is our management IP address that we can connect into on switch B1 to manage that. If we look here, is there anything else using, oh, this is a 1 here, not an exclamation mark. Is there anything else using a network similar to this? Up here, branch 1 is using 192.168.1.1 with a /24. So this first 3 octets is the network address with a /24. If we come down and look at our address, that's the same one, 192.168.1. So our subnet mask is the same as that. So it's 255.255.255.0. And our default gateway for this, we really can't tell here. We can make a guess, but let's figure out a way to tell what it is. So we're looking for that information. We need to figure it out. We are currently here on branch 1. Okay, well, if we enter out, can we telnet into that IP address of which branch 1? So into 192.168.1.252. Trying, okay, so it's asking for a password. Let's try our Cisco, our VTY password. Hey, we're in. Type in enable, try class. Look, we are in there. Now we can go ahead and do a show IP interface to look and see what our information is. So show IP interface. Okay, VLAN 1 is up and up. Our protocol is, our address is 192.168.252/24. That's what we have right here. That's looking good. Spacebar through there. That's looks like the only interface we have that's configured. Let's go ahead and do a show run and go down to our interfaces. At the end of our interfaces should be our VLAN. And here's our subnet mask and our default gateway. Our default gateway is 192.168.1.1. We have information for SB1. Okay. So that's the switch that lives between PC1 and branch 1. Let's go ahead and look at PC2. PC2. We lost our connection. Let's go ahead and reestablish it. Up arrow 1s. Cisco enable class. We're in there. Let's do a show CDP. Let's do a show CDP neighbors. And we have 2 switches configured here. We have 2 switches connected. We figured out that that's PC2 and PC3. Let's go ahead and take a look at this one. Let's go ahead and telnet into the first one, SWF1. Well, how do we do that? We have to do a show CDP neighbor detail. And then here's SWF2. We figured out that SWF2 was connected into PC3. So I can draw that on my diagram here. So that is connected into PC3. So this is SWF2. And I can also write that IP address down there, 192.168.4.252. If I hit spacebar again in my PC2 window, here is, scroll up, here's SWF1. So SWF1, which that goes between PC2 and factory. That IP address right below is 192.168.3.252. Let's go ahead and telnet into those. So telnet into 192.168.3.252. Cisco enable class. Oh, I typed in the wrong password. Let's go ahead and try that again. Telnet. Cisco got me in. Type in enable for privilege exec mode. Class. We are now in there. Go ahead and do a show CDP neighbors. We are only connected to the factory device, but we need to get our IP addressing information so we can connect into it. Actually, we're looking for our subnet mask. We can get our subnet mask from doing a show run, going down to our VLAN 1 information. Here's our subnet mask. It's another /24 and our default gateway. So we can get all of our information there. Once again, we are on SWF1. So SW-F1. We are on VLAN 1. Oh, on switch SWB1, we are also on VLAN 1. This is a switch. Our IP address is 192.168.3.252. Default or subnet mask at 255.255.255.0, and our default gateway of 192.168.3.1. Okay, so that was SWF3. I'm going to go ahead and type exit here. That'll end my telnet session. We're back on the factory one. So now I can do telnet. And looking at my diagram, I can telnet into that SWF2 switch, which was 192.168.4.250, I think is my handwriting. Oh, maybe not. 252. Oh, my handwriting was wrong. Let's try 252. Yep. That's a 2. So we type in Cisco for our VTY password, type in enable, and class for our privilege exec password. From here, let's do a show run. Take me down past my interfaces to my VLAN information right here, IP address, subnet mask, and default gateway. Let's go ahead and document that. SW-F2. We are on VLAN 1. This is a switch. Our IP address is 192.168.4.252. Subnet mask at 255.255.255.0. And our default gateway 192.168.4.1. Oh, this is peculiar. As we're looking here, each one of these management interfaces, well, first off, VLAN 1, you shouldn't use VLAN 1, so that's another thing we can pay attention to. Shouldn't use VLAN 1 for management. I'm writing that down on our list of suggestions. Plus, each one of these are on the VLAN, or an IP address on the VLAN they serve. They should be on their own separate VLAN. So management should be on its own VLAN. Okay, so that was SWF2. I'm going to go ahead and type exit out. I think that was the last one. If I do a show CDP neighbors, yep, SWF1, F2, I have that, and our hub. Okay, that's looking pretty good. Now, looking at my diagram, PC2 and PC3 were connected to the same router with the same switches, and I have that all documented, so I don't need to go into PC3, but let's go ahead and go into PC4. Reestablish my telnet connection. Cisco enable class. Do a show CDP neighbors, and I have an SW-HQ1. SW-HQ1 looks like it is a device that is directly connected to HQ. So I'm going to go ahead and do SWHQ1. Now let's go ahead and telnet into SWHQ1. But to get that, we need the IP address. So show CDP neighbor detail. Here is SWHQ1. Here's its IP address. Let's go ahead and document that. 192.168.6.252. Now we can go ahead and telnet into that. Okay, so telnet into that IP address we just figured out, 192.168.6.252. Cisco enable class. We can go ahead and do a show run to get our information from that. Take me down past the interfaces. Oh, look at this. We've got trunks here. We have some trunks. We go down to the end here. Let's go up and look at the beginning. We actually have port channels. That means we have connections between switches. So we have more than just the one switch we're on, the SWHQ1. We've got some other switches we're connected to. Okay, so let's document here our SW-HQ1 first. Document that information. Here's that information, VLAN 1 with its IP address and default gateway. So VLAN 1, this is a switch. IP address is 192.168.6.252. Subnet mask 3255s, and our default gateway 192.168.6.1. Okay, because we noticed we have these port channels, we have these interfaces, we have multiple interfaces belonging to the same channel group. That means we're connected to another switch. That means we have more than just one switch there. How do we figure out what we're connected to? Let's do a show CDP neighbors. Oh, look at all of these neighbors. So we're connected to HQ. We have our sub interfaces on HQ, but we also have switch HQ2, switch HQ2, so we have two fast Ethernets making one port channel. Here is switch HQ3. We have fast Ethernet 23 and 24. Wow, we've got quite a lot going on here. We've got some port channels. Oh, so our drawing right now, my drawing is a mess. It's going to get even messier. What I'm going to do is I'm going to start going from HQ and drawing backwards to my end devices. I'm going to get out a new sheet of paper, a whole third sheet of paper, and I'm going to start drawing there. And so I have HQ here, the router that goes down to the device we're on is SWHQ1. From HQ1, I have port channel 1 going out to HQ2. So I'm going to draw SW-HQ2. And I'm going to draw another square for SW-HQ3. And I have port channels here. Now, it looks like for HQ3, I have two physical ports, so we're connecting two of those together. And I have, looking here, HQ2 has fast Ethernet 20 and fast Ethernet 20 or 19 and 20. Okay, so I know they're connecting in on 19 here, so I can write down fast Ethernet 0/19, fast Ethernet 0/20. Over here, going into HQ3, I can write down fast Ethernet 0/23, fast Ethernet 0/24. I do know the IP address here on VLAN 1 from HQ1. I have that written down here. So VLAN 1 here for management was 192.168.6.252. That was a /30. These ports, my local ports here, it says port channel 1. If I scroll up in my running config, I am looking for access group 1 on my local configs here. It's port 19 and 20. It goes to port channel 1. So fast Ethernet 0/19, fast Ethernet 0/20. I can also say that this is port channel 1 here. This is port channel 2 over here. And port channel, no, this is port channel 3. Oh, going down here, yep, port channel 3. Port channel 3, right here, we're using fast Ethernet 23 and 24. So this is fast Ethernet 0/23, 0/24. Once again, not pretty at all, but we're doing initial documentation for that. So those are connected with trunks. We do have those, but we don't have the IP addresses. To get the IP addresses, what we have to do is do the show CDP neighbors detail. Now when we do that, we can see that we are connected here to the HQ router, which we have the information for. But then we have the SWHQ2 that has an IP address of 192.168.6.253. So I can write that down, 192.168.6.253. So that'll allow me to telnet into that one. If I see that there's more information here, so I can hit the space bar. Okay, so here was SWHQ2. Here's some more information about the HQ router. We're not important about. These are the sub interfaces, so we're going to see several of these on sub interfaces. But what we're looking for is HQ3. So here's SWHQ3 with its IP address 192.168.6.254. That's the IP address of the VLAN. I can go ahead and write that down, 192.168.6.254. That's for the VLAN. As we look here, we can see that we have one for SWHQ3. That's one. Then we have a second one here for SWHQ3, and we have a third one for that. Well, what's happening here is this first one, SWHQ3, is for fast Ethernet 024. The second SWHQ3 is for fast Ethernet 023. Then we connect those all up, and the third one, SWHQ3, is for our port channel. And this is the IP address we are looking for. Okay, let's go ahead and take a look at that. And let's go into each one of those devices to see if that's actually the end of those. And so we can telnet, and I'm going to connect into HQ2. Oh, let's go ahead and update our information. So SWHQ2 is a VLAN. I'm not sure what VLAN, so I won't put a number, but it is a switch. It's looking here, our connecting into SWHQ2 is 6.253. So 192.168.6.253. Don't know exactly what our subnet mask is, but I'm willing to bet it's this same one here. And we don't know what our default gateway is. We'll have to get into that switch to figure it out. But let's go ahead and document SWHQ3 with its IP address. So SW-HQ3. It's a VLAN. I don't know which VLAN, so I won't put a number in there. Switch. Its IP address is 192.168.6.254. We can't tell the subnet mask here or what its default gateway is, but we can connect into them. So let's go ahead and telnet into SWHQ2. Its IP address is right here. Once again, I have that all written down on my map, but we also have it in our addressing table. So 192.168.6.253. We're telnetting into that address. Cisco is our VTY password. Enable. Class is our privilege exec password. Let's go ahead and do a show run. Spacebar down to apt our interfaces to VLAN 1 here. We can see that this is our IP address, subnet mask, and default gateway. So let's go ahead and enter that in, 255.255.255.0. Default gateway is 192.168.6.1. We have a port channel here. We have 2 port channels. So let's go ahead, look at our CDP neighbors. So show CDP neighbors. And that gives us, we have 2 port channels. One we are connecting here. Port channel 1 goes into HQ1. That's where we just came from. And now we're on HQ2 and that connects into HQ3. So HQ2 and HQ3 are connected by a port channel. So I'm going to draw 2 lines representing our connection there. Far interface here, this is F0/21, F0/22. This is port channel 2. So I'm continuing to draw it. I just do that connection between switch headquarters 2 and 3 on the bottom with the 2 channels. Let's go ahead and look. We're looking for port channel 2 up here. If I scroll up and look at my configurations, here's channel group 2. So we're using fast Ethernet on our local device of 0/21. So fast Ethernet 0/21 and fast Ethernet 0/22. That's our connection. So that's our last connection there. Last thing we have to get here is our subnet mask and our VLAN information. This was VLAN 1 on HQ3. So from here, from HQ2, I can go ahead and telnet into HQ3, which that IP address right here from our addressing table, or you can get it from the map you're making, 192.168.6.254. Cisco is our password. Enable. Class is our privilege exec password. And let's do a show run. Take us down past the interfaces to our VLAN information. Here we are, VLAN 1, IP address information, and default gateway. So our subnet mask is 255.255.255.0, and our subnet mask is 192.168.6.1. Okay. We have come to the end of all of the devices because they all led into other devices we've configured. So there is a hub at the center of all of them connecting up all of our devices. On to part 5. Further explore device configurations and interconnection. Access device configurations. Connect to other devices in the network. Gather information about the device configurations. Uses discovery protocol. Knowledge of the network topologies. Connect to other devices. Display configuration for other devices. Record your findings. We did all of that as we went through and we filled out our chart. As we finished here on step 4, reconstructing our topology, we connected in there. We did all of that information. So we have our table completely filled out. IP addresses, this is all of the devices on our network. We have 7 PCs. We have branch 1 router. We have a factory router. We have an HQ router. We have a branch 2 router. And then we have a hub router that connects all of them in there. Then we have some switches that give us our LAN connectivity to our end devices that are connected up to those switches. Reflection. You may have noticed that some practices used to configure the network devices are out of date, inefficient, or not secure. Make a list of as many recommendations that you have regarding how the devices should be reconfigured to follow the practices we have learned and talked about. Well, going back, I had a list of a couple things. First thing is use SSH instead of Telnet, because Telnet sends your data insecurely, unencrypted across the network. SSH will do that securely. The next one here is do not use VLAN 1 as your management VLAN. So make sure you don't use VLAN 1 to connect into your devices. Up here, that's what we're connecting into. Here is VLAN 1. All these were on VLAN 1. It should be a different VLAN. Also, ties in with that, management should be on a controlled VLAN where not everybody has direct access to that. Now, as we look through this, there were several other things that we could have done. The devices that weren't being used aren't shut down. So scrolling up here, we can see that the security on these ports, if they're not being used, they should be shut down. So shut down unused ports. There's no port security, so it would be, come on, enable port security would be another one. Looking here, we can also see that OSPF was active on all of our interfaces. To show you that, we can go ahead and exit out. We are now on the HQ device, exit out again. We are on HQ1, exit out. We are on the HQ router. If we do a show run, we can see that OSPF is being propagated out there. We're doing nothing to stop OSPF from being propagated out. We can also see that the area 0, some people would consider this a small network or a big network. You could make it into different areas. That would help give you some security. But the big thing here is we're propagating OSPF information out of end devices. So do not propagate OSPF information out of end device ports. Nowhere as we looked at this did we see anything to do with access control lists. So we should be looking for access control lists. So there's no access control lists anywhere. Use ACLs for security. We can also look for different things for authentication. We aren't using any 802.x, so we could implement 802.x, implement 802.1x. We could implement that, give us better security. CDP was on by default. You should only have CDP implemented when you're using it and only to the other devices that need it. So limit CDP usage would be another thing we could do. And one of the last things I noticed was we have DDP, Dynamic Trunking Protocol, was enabled on all of the ports, and that's a security risk. So disable DDP when possible, which should be pretty much all the time. That was Packet Tracer Lab 12.6.1 Troubleshooting Challenge, Document the Network. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.